Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Dataways. This week we'll be talking about what's new in Apache Iceberg, updates, PyIceberg, compute engines, and more. Oh my! Now, of course, before we get into our feature presentation, there's all the fine announcements I'd like to make, such as heading over to Dremio.com and trying out the test drive feature. Within a few minutes, you can get hands-on with Dremio in the data lakehouse with no cost, no obligations, to kind of get an idea of what the fuss is about. So head over to Dremio.com, give it a try. Why not? But also make sure to pick up an early copy of our Apache Iceberg, the definitive guide, a new book from O'Reilly, slated for early release early next year. But you can get your hands on the first couple chapters now by just scanning that QR code. The early release was just updated, so has additional content. Okay, so go check that out. Um, Also, we have plenty of great episodes coming down the road, such as machine learning, experimentation, reproducibility on the lakehouse next week. After that, Dremio the data lakehouse table formats. Um, the week after that, getting started with Dremio data reflection, simplifying data mesh with Dremio's open data lakehouse, best practices for building a data lakehouse on ADLS, versioning data in the data lakehouse, file, table, and catalog versioning. So lots of great content coming in the next couple months. So make sure to keep coming every Tuesday to catch all this content. Also, Dremio is partnering on AWS on these following events. So if you're in any of these areas during any of these dates for these events, make sure to attend. You'll have a good time, whether it's an AWS Dev Day or an AWS Summit in Chicago, New York, Toronto. Yeah, check it out. Also, Dremio will be present at many of these international um, events, such as Big Data and AI World, Data Festival, Coalesce, Big Data London, Big Data and AI Paris. So make sure to be there, enjoy it, check it out, have a great time, and stop by the Dremio booth for some cool swag. But with no further ado, let's head on to our feature presentation with what's new in the Apache Iceberg project. So we're talking about updates, PyIceberg, compute engines, and more. And with no further ado, fellow developer advocate here from Dremio, Dipankar Mazumdar, the stage is yours.
Hey everyone, welcome to this new episode of Nali Data Waves. Our today's session is about what's new in the Apache Iceberg project. So let's get started. A little bit about me. I'm currently a developer advocate here at Dremio. My background basically is into BI, machine learning, and data architecture. I right now focus on a couple of open source projects here in Dremio, like Apache Iceberg, Apache Arrow, Project Nessie, along with the Dremio's Lakehouse platform as well. But one thing that we are super excited about is that we are writing the first book on Apache Iceberg. So that is something very interesting. And it's basically on an early release program. So feel free to check it out from Dremio's website and read the first two chapters. They are already live there. If you have any feedback that you might want us to get back to, I think that's a really good option as well with this early release program. So yeah, reach out to us and we'd be happy to get any feedbacks around this. So in terms of the agenda, we will first go through a bit about how the Iceberg community looks like today, how it has grown over time. I think community is a huge focus, and I think I just wanted to discuss a bit about it today. We haven't really gone through that aspect, in our present webinars. So that's one thing. Then we recently had the Iceberg 1.20 release. So we will go over some of the critical updates of the release and how it can benefit data engineers and the community in general. And then we'll talk about some of the key new capabilities that Iceberg added in the past few months. And I think these capabilities are some really important ones. I think really they are now natively available. So I think that's really good. And then we will switch gears from the Spark and JVM world to the Python world, kind of with Iceberg, and see what's happening, what's really what should we look forward to with the PyIceberg API as well. And then finally, we will end the discussion with compute engine updates, for example, updates from Spark, performance side, Apache Flink, and Dremio compute engine as well. So let's start a bit by talking about the Apache Iceberg community and communities in general. So I have a quote here that I put together based on the experience of me being part of open source communities in general, which is a developer community is not just about the code, it's diversity and about creating a space where ideas flourish and individuals really inspire each other to make sure that the community can move forward with such a direction. And to that, I would like to add that one of the core strengths of the Apache Iceberg project is its diverse set of contributors and the community in general. So the project has really witnessed remarkable growth in terms of the community since its inception. Basically, we have had a lot of talented developers from diverse backgrounds and organizations contributing to the project. And now, if you see, we are going to look at some of the metrics, but in general, the project has really seen a dynamic growth. So one of the medium that allows us to be a part of the Iceberg community is through the official Slack channel, where we can discuss issues and receive latest updates, etc. But also there are other avenues such as the developer mailing list. Highly recommend to be part of it so that you can get any latest updates around releases of Iceberg. Then there is this bi-weekly community sync meetings, which is again a really good avenue to voice your opinion about any PR, any existing work that's been going on with the project. There is also a Twitter page that's run by advocates called Iceberg Devs Apache Iceberg Community. That is also a good place to, in general, learn about what's happening in the project. A couple of interesting blogs and codes shared over in that particular account as well. So here are a few recent metrics that I thought might be interesting for us to take a look at in terms of how the project has evolved in terms of community, right? So first, there is the GitHub star history. And although GitHub star isn't really a key metric to decide how the project is doing, but I guess it does gives us a sense for the interest of the overall project. And so we are close to 5K, and with the time, the interest is only increasing. So that's a really good sign as well. That shows that the project has a huge momentum and communities are adopting to it, the organizations are adopting to it. So that's really good. If we take a look at the PR history, again, we see a lot of new PR, meaning either they are new features, improvement, or bug fixes. And of course, the graph is monotonically increasing, which shows that there is a huge momentum and growth of the project in terms of the code. So that's again a great sign where we have some direction towards understanding what's coming new and how we are really contributing to that project in terms of the code. And on the right hand side, we have the diversity of the PR creators. So these are basically the pull request creator by the companies. So each of the bubble that you see here is basically an organization. And as you can see, there are a lot of bubbles. Which is amazing because it displays the diversity in the project. We have so many people contributing from so many organizations. And this is what I was referring to in my first slide, that there needs to be a diverse set of contributors in the project. And that really helps us to have kind of non-biased decisions and just work towards a common community goal, right? So we have folks from Tencent, Netflix, Dremio, Tabular, Apple, that really strives hard to make the project successful. And I think that's something really commendable. So really thanks to all the contributors as well. So moving on, we will switch gears from the community part to learning more on what has happened in the project in the past couple of months and try to see what the latest features were, probably what should we look forward to in the future. And to start with, the Apache Iceberg 1.2 was released a couple of weeks back, and this release has once again brought in a variety of new features, performance improvements and bug fixes around the core library, compute engine parts, vendor integration, ultimately making the entire ecosystem around Iceberg extremely robust. So that means it also makes it easy for people to adapt it and easily grow and take it over from just being an open source project to incorporating and integrating with various other technologies in the market as well. So if we start with the core library, there are so many exciting new changes. First is the ability to personally, I was really looking forward to this. It's called branching and tagging feature. It's basically an ability to create branches and tags in Iceberg. And we will deep dive more into what this is in the next slide, but it's a great feature to have as well. Brings in a data as code approach, so that's really nice. Then we have the Delta Lake to Iceberg migration module, which is another very interesting feature. If you are looking for migrating your Delta Lake tables to Iceberg, this is something that's going to be helpful. Next, we have the enhancement on the user experience side for developers and data engineers, such as basically adding human readable metrics. These things really add value at a granular level. So really great to have them for debugging purposes as well. Yeah, so that's something important. And there are also things such as Puffin stats file reusability and file IO support for org files, which we are going to touch a bit about in the next few slides. So branches and tags, what are they and how do they help in Apache Iceberg, right? So let me give some analogy here. So the concept of tags and branches is well known in the software engineering world, I guess, particularly with version control system like Git and GitHub. Basically, developers, they create their isolated local branch to, let's say, add in a new feature or fix a bug. You basically commit the necessary code changes, and after that, you send the code for review, right? And once that particular code is reviewed and make sure everything is in line and doesn't really impact any production environment, the branch is merged to the main environment, which makes those new features available in production environment, right? So that's the usual process that we have been working in the software engineering world. Similarly, tags in the Git or GitHub refer to a specific commit. For example, I basically wrote some code, I committed it that, and I created a tag around that saying that, hey, this is the code that's for a particular version of the release. So this can be really helpful when we want to point to a particular release and go to a particular release. So tags are really beneficial in that case. Iceberg's new branching and tagging capability borrows similar concept from the Git world and applies it to the world of data lake and lakehouse space. So basically, it enables data engineering and data science team to keep track of the state or version of an Iceberg table using name references. So to understand the concept of branch and tags in Iceberg, you will need to go back to one of the core Iceberg component, which is a snapshot. So just to give a quick refresher, Apache Iceberg maintains the state of a particular table at a certain point of time using a concept called snapshot. So now every time you do a write operation, for example, you do like an update or delete, it changes the current state of an Iceberg table. That's when a new snapshot is also created, and it is used to track that version of the table, that new changes that were made. And that particular snapshot is then marked as the current snapshot. So this ensures that readers always fetch the latest version of the table for the clients making a query request, right? So if I am like, for example, there was a write operation and, I, as a reader, I'm trying to query that table, I would always look in for the latest version of the data. Otherwise, we don't have the latest version, and that's a staleness issue. So until now, the only available reference in Iceberg was the current snapshot ID. So that's what the only available named reference was. Okay, so this is a new update, and this is a new snapshot. I'll mark this as a current snapshot ID, and I will use that current snapshot ID to basically do all my operations and stuff. However, with this new release, the references can now be extended to include tagging and branching of tables. So basically, we are extending the name references from just the current snapshot to being branches and being tags. So tags are basically, let's try to understand like what tags and branches in general are, and try to look and see some realistic applications as well. So tags are basically immutable labels for individual snapshot, and basically they refer to a specific snapshot ID. So for instance, let's say you're working on an Iceberg table called employee, right, which has data until the month of June. You probably can see on the screenshot on the left as well. And you want to use that particular version of the table to, let's say, train a machine learning model, or let's say, you want to do some analysis on that particular June data, right? So this is a scenario where you can basically create a tag and basically label it and say, hey, you know what, this is the June data, and I'm going to use this particular June data to train my model, or, just, do my analysis based on this particular data, right? So those are the concept of tags in Iceberg. So it's basically, like I said, it's the same as like Git tags as well. It's just, it's a commit. So any commit that you make, it's a tag. So again, these are immutable. That means you cannot really change any tag. So, you cannot really make any changes to that particular tag. It will just be existing there, depending on a period that you want to keep it for. And any further changes that you make to the main branch of that particular, data set or a table will not impact this particular June's version of the tag. So this particular tag is isolated from the other production workload, right, which is the main branch's workload. So that's a great use case to have, because you can, like I said, you can use it for your data experiments, you can use it for machine learning reproducibility and those kind of version specific analysis. So one of the things that you have to do to create a tag is just use a SQL statement. In Iceberg, it's basically a SQL API. So just say, hey, alter table, and just create a tag, and that's all you're set to use that particular tag. Now, moving on from tags, we come to the concept of branches. The only difference between branches and tags are that the tags are immutable and branches are mutable name references. So that means, unlike tag, you can actually write data to a specific branch. And these writes adhere to the Iceberg's commit conflict resolution and retry principles. So basically, it uses a concept like optimistic concurrency control to ensure there are no commit conflicts. So what it does is Iceberg, basically, if there are some write happening, that particular write will complete. And in the meantime, if there is some other write operation trying to happen, that will fail. and Iceberg will ask that particular operation to try it again at a later point of time. And that's how you kind of like use this optimistic concurrency control to ensure there are not really any write conflicts. So as of now, we can write to branches using basically an identifier, that is, let's say a branch name or a WAP ID. What is a WAP ID? Basically, WAP is write audit publish pattern, which is basically something that I'm going to discuss in a few minutes. Basically, it's branches opens up a whole new avenue for some of the interesting use cases. And like I was saying, implementing write audit publish is one of the important application of branches, I would say. So write audit publish is a pattern in data engineering workflows that ensure data quality checks. So with Iceberg's branching capability, you can now create branches, and basically you can just write data to that new branch. And you are not impacting any production data based on that, right? So you're just writing data to a new separate isolated branch, and then you can run your data quality checks and do your audits and stuff. And once you're satisfied with the particular data quality checks, you can advance it to the next stage and basically promote it to the production environment. So that's a great use case for having something like branches in Iceberg. So it really facilitates this kind of pattern and makes things independent of production workload, which is super important when we're dealing with this kind of data stuff. Another important use case that I usually like to talk about is about isolated data experiments. Branches can be extremely beneficial for our isolated data work. For example, experimentation is a huge aspect in machine learning space, right? So it helps researchers and engineers build robust models. So you need to be experimenting with different kind of probably feature set or different kind of like a later space. So in such workload, you can create an isolated branch from an existing table, so without any data copies. So usually when you don't have such kind of an ability, you try to like copy that particular data set and manage those different set of copies, and then try to create experiments or models around that. But what we are doing here in this case is that you're just creating an isolated branch of that particular table without making any data copies, and then you carry out your experiments. And if you decide, okay, this experiment wasn't really successful for me, you can just drop that particular branch and you don't need to worry about it anymore. Or if your experiment was successful, you can basically decide to basically advance that particular version of the table to the latest table version. So this capability guarantees your experiments have no interface, like I was saying, with the production workload. So that is super important to have as well. And again, there are other use cases, like, for example, you can do ETL load testing. You can basically, load some data, ingest some data to a particular branch. You can do your QA and decide to move forward with that if you like it. So these are some of the great use cases of branching and tagging, and I think the new version really, allows us to do and enables us to do those kind of thing. So yeah, I can share a few, articles and videos that we kind of recently did about these kind of aspects as well. So next, we have the Delta Lake to Apache Iceberg migration module. Again, this is another much awaited capability. And like I said, and obviously you can have a numerous reason to migrate from Delta to Iceberg. For example, you may want to take advantage of certain critical features such as partition evolution, hidden partitioning in Iceberg. So these are the features that are really that really separates Iceberg from other table formats. So you might want to test out these features, or you may just want to basically be a part of a diverse community where there are really no confusions about what is open source, what is not, and irrespective of whatever the reason is. It is important to have a capability to do this type of migration, from Delta to Iceberg. So until now, there were two ways to do a migration. One is the in-place migration, where basically the goal is to repurpose the files from the previous format into the new format to reduce the amount of data that has to be rewritten. So rewriting data is always a costly approach. So the in-place migration takes place of repurposing the files from the previous format. So this approach results in just taking the existing Parquet files from a Hive, Hudi, or Delta Lake and registering them into a new table, Iceberg table. The second way of doing a migration until now was called shadow migration, where we basically rewrite the table, often using a CTAS, like a create table state as statement. And this works for migrating data from any source, such as Hive, Hudi, Delta Lake, relational databases, or any source that the engine can really read from while basically writing to an Iceberg table. So I think shadow migration and in-place migration was already existing until now. However, this new module brings a bit more agility to the migration strategy, I would say. So now we have an Iceberg action module called snapshot Delta Lake table. As you can see in this particular screenshot, the green box, Basically, it reads the Delta Lake table's transactions and converts them into a new Iceberg table with the same schema and partitioning scheme as we had in Delta. So it is important to note that the original Delta Lake table here remains unchanged in this particular process after we create the new Iceberg table. So the newly created Iceberg table can be changed to or returned to without impacting the source table at all. So any new change that you make, it will be fully independent of the new of the old source Delta table. But the snapshot of the new Iceberg table, they still uses the original table's data file location. So when new inserts are overwrite to run on a particular snapshot, new files are placed in the snapshots tables location, right? And that location, like I said, is the default location of the Delta Lake table. However, users can also decide to specify a different location for the snapshot table. So that really helps if you want to really change the location. But again, if you want the files to be under the same data lake, that's already there with this particular module. So all you have to do is particularly run this particular, call this particular action in Iceberg. You can use the Java API to do that. And once you do that, all this existing files will be migrated to Iceberg and Iceberg snapshot. And like I said, the partitioning scheme and schema will all be maintained. And hopefully it gives us a much agile way to do this kind of migration as well, along with the existing in place and shadow migration. Another improvement made on the user experience side of thing is adding the human readable metrics for metadata table. So Apache Iceberg's metadata table can be super helpful during debugging and getting an idea around the overall data lake's health, right? Or the partitioning strategies, statistics, and those kind of informations are really beneficial. So particularly the files metadata table allows us to know the upper and lower bounds, value bounds of each other column, right? And this can be extremely useful for scenarios such as checking if a column is properly sorted and those kind of things. So if you are aware of these particular values, you can basically also do debugging whenever when you think, okay, maybe these are not properly sorted. Maybe there is some problem with that. So those kind of debugging elements are really important. And as long as you see a human readable metrics, I think it helps you to do those kind of debugs as well. So the caveat until now was that these metrics weren't human readable. And if you can see the screenshot to the left, you can relate to what I'm talking about. So you have basically the bytes, and you see some values around that, but really you can't make any sense of it in a human readable form. However, the new release version makes this metrics interpretable by human and readable using SQL. So, if you see this screenshot on the right, now you can see the actual values, and these are the values that can be interpreted and be read by human. So you can do your debugging and analysis as well. So again, this can also be read using SQL, and you can basically use the SQL query like I presented here, and you can basically read all the data using this. It's basically, these changes might look trivial, but they really have an impact on the overall experience of the developers, and I think that's super important for the community in general as well. So before we move on to our next part, just quickly, I want to go over two of the other core library changes which I didn't cover, but I thought I might be able to cover. So one is the Puffin stat file reusability. So Puffin file, just to give you an idea at a high level, these are basically a type of statistics file in Iceberg that can store large blobs. In more simpler term, they are basically statistical information that cannot be stored on regular formats such as Parquet or ORC, as their size can be of significant higher magnitude. So you need a separate set of file to store this blob. So that's when Puffin file was introduced. And until this release, we had snapshot ID in two places, one in the statistics file and one in the blob metadata. However, in order to support the reusability of statistics file, because we're going to use the statistics file these are going to be used by the engine, and this needs to be reusable, that would make it more efficient. So we should have the reference snapshot ID in the statistics file, not the computed from snapshot ID. So this particular spec change was made to reuse the statistics file reusability, and basically, the engines can reuse it and employ it. And the other one basically adds support for file IO with Apache Arc. Without this change, Arc is unable to leverage the benefits of file IO, better file I would say, such as S3 file IO, for example, compared to S3A file system. So although a small one, but really it adds value for people leveraging Arc on systems such as S3 with Iceberg. Okay, so now we will talk about some of the key capabilities that Iceberg recently added, and which I think can add a lot of values for data engineers and organization. Uh, First is the change data capture, more commonly known as CDC, and probably you might be aware of CDC at this point of time. Uh, but CDC is a really critical impact for our data pipelines. It allows us to track changes to our data and helps record them in real time. So things like any changes to the data, for example, inserts, update, deletes on a particular table, those are recorded in real time. And CDC is commonly applied in scenarios such as data integration, real-time analytics, auditing, maintaining synchronized data across multiple systems, and those kind of stuff. It enables organization to basically efficiently track and react to data changes, and allows you to propagate updates to downstream system, so you can derive insights from the real-time data stream. So that's a really important feature to have. So such a critical capability was much needed for Apache Iceberg tables, because the downstream applications might be dependent on it, and you need to be aware of it. And the latest release brings this functionality natively. So you now have the ability to do this natively in Iceberg. So Iceberg CDC allows you to track changes made to your Iceberg table over time. And it basically allows you to save this change log for auditing purpose or ingesting them into downstream tables incrementally. So what you need to do is basically run a Spark procedure called create change log view. And as you can see on the screenshot here, basically we have a procedure called create change log view that basically takes the table name and a couple of options. So in this case, it is using the start snapshot ID 1 and the end snapshot ID 2 to capture the changes based on these particular snapshots. And it basically creates the change view table based on these particular snapshots and records any changes. So in this example, it shows that the first snapshot, basically it inserted 2 records, as you can see in the output. And the second snapshot, it basically deleted 1 record. So, these kind of changes are being tracked now, and you can track these changes, and you can make sure these changes are reflecting in the downstream application or your auditing journey as well. Moving on from CDC, we have the beta release for the new Apache Iceberg Catalog Migrator tool. As we all know, Catalog is a key component of the Apache Iceberg architecture. It is a logical namespace that basically contains information about how to fetch metadata about tables. So most importantly, the catalog basically it holds the reference to the current metadata pointer. That is the latest metadata file. So there are a few scenarios when you want to migrate your Apache Iceberg tables from one particular catalog to another. For example, just to give an idea, you might just be starting out and testing Iceberg as a table format for your data lake, and basically have used a file system-based catalog like Hadoop catalog, which is backed by the Hadoop distributed file system. So typically, the Hadoop catalog is not recommended for production users as it has no reliable locking mechanism, and it would impact concurrent read and write. So there would be no way to handle those concurrency. So at this point, you would have to migrate your catalog to some production-ready option, right? Because you might be testing, and now you have decided to go ahead with your productionizing Iceberg. So you need to move to a catalog which is production ready. So until this point, there was just one way to achieve a migration between specific catalog, and that too it was limited within different catalogs. So the one way to achieve that was using the catalog.register table interface from the Java API, which sometimes it was confusing for people. Sometimes people don't use the Java API, or whatever reason, or sometimes the option will limited. But this new CLI tool, it's basically a CLI tool that enables bulk migration of Iceberg tables from one catalog to another. So if you have thousands of Iceberg tables from one catalog, you're good to use this particular tool and bulk migrate the catalog tables from one catalog to another. And most importantly, without even the need to copy the data. So you're not really making a data copy, right? So that's super important because it really helps. So the tool supports all of the commonly used catalog in Apache Iceberg, such as AWS Glue, Nessie, Dremio Arctic, Hadoop, Hive, REST, whatever it is. The tool is currently an open source project with Apache license under the project Nessie. So you can download it from the GitHub link and mentioned here. You can just go to this particular GitHub link and download it as a CLI tool. And you can basically, as you can see in this particular screenshot, I have specified a few things here. For example, here in this example, I'm migrating from Glue to Nessie. So here I'm specifying a few properties around Glue. For example, the warehouse location, what is the implementation, then the target catalog type and the target catalog properties. For example, the URL of Nessie, what is the warehouse location on Nessie, and those kind of stuff. and I'm migrating here only one table, which is just the nominees table. So basically, if you execute this command, you will now have this particular table from Glue to Nessie. So, that's something amazing. I also recently wrote a detailed blog on this, which I can share after this webinar. I think that would also really give a good idea. Basically, I wanted to discuss about two scenarios. I think we might not have the time to do that. But again, the blog would be super helpful to do that. But in general, here, just an idea. In one of the scenarios, we are migrating from the Hadoop catalog to Dremio Optic, which is a production-ready catalog. So what are basically, there are a couple of steps. For example, you identify the table for migration, then you start the migration and you finish the migration. And similarly, in the below case here, we're migrating for something like Glue to Nessie, and that's basically the similar way. It starts the migration and finishes the migration. And one important thing that I want to take a note from here is that here you see the source table was deleted, right? The nominees table doesn't exist in the source catalog now. However, in the Hadoop catalog, the source table still exists. That's not deleted from the catalog. The reason is for that is that with Hadoop catalog, you cannot migrate the table. You can just register that particular tables, because it might be tricky to do that because it has no locking mechanism in general. So I think it's important to have just the ability to register tables. So in Hadoop catalog, we're just registering the table. That's why we have still a couple of tables in the source catalog. However, with catalogs like Glue, which is non-Hadoop, there you basically end up deleting the table, and all the tables are migrated to the new catalog. Now, moving forward, I think we can discuss a bit about how Spark in general has, as a compute engine, has improvised in this particular release, and how it brings some major performance improvement, which is super interesting even for me as well at a personal level. So let's start with some of the Spark-related performance updates. So number one is the support for storage partition join in Spark 3.3. So in Apache Spark, there is a concept called storage partition join. Basically, it's a type of join operation which is performed on distributed data sets that are partitioned across a cluster of machine. So when working with larger data set, it's obviously common to divide the data into partitions, right? It's a very common strategy that we have been doing it from the world of databases, for example. It basically helps you to distribute the processing and storage across multiple nodes in a cluster. So in the case of storage partition join, both datasets that are involved in the join are partitioned, and the join operation is optimized to leverage the partitioning scheme. So this basically reduces the amount of data that needs to be transferred between the nodes, and that's how it speeds up the joins and the performances. So the support for storage partition join is now made available for Iceberg table in Spark 3.3. So that is super interesting to have, and we might have to run. I haven't personally tested this out, but if you have tested it out, reach out to me and let the community know, or the Slack channel know that how those changes have really impacted your performances, and really if it makes an impact in general. Next, we have the change for automatically setting certain Apache Arrow environment variables for improving the read performance. So Apache Arrow is a in-memory table, columnar table format, which is used, a columnar format, which is used by the Iceberg project to deal with reads and those kind of things. So there are a few Arrow-specific settings, environment variable, I would say, that needed to be turned on explicitly. Otherwise, we saw significant impact on the read performance. These changes basically makes setting these properties automatic. So now we don't have to explicitly set these properties ourselves in the new version. So we basically there were a lot of bugs that were reported when we were testing out TPC-DS data set. We saw kind of impact to the read performance when we didn't have these particular settings turned on. So now with these new settings, I think which is automatic, you don't have to explicitly do anything. You can just take the benefit of read performance. Then we have the aggregate pushdown support for min, max, and all kind of columnar, aggregate functions to improve read performance. So if you do something like, for example, today, without 1.2.0 release in Iceberg, if you do something like select min of column or max of column or count of column from a table, without this particular PR, Iceberg will basically select that particular column from the table, and it will pass on the calculation part to Spark. So Spark will do the calculation of minimum column or maximum column, and it will return the results. However, with this PR, Iceberg will do select minimum column or maximum column. So basically, the calculation is now on the Iceberg side, and it uses the statistics info on the manifest file of Iceberg, which basically allows us to do things like partition pruning and data pruning and improving the read performance. So really having that calculation part on the Iceberg part and shifting the responsibility towards the Iceberg side and leveraging Iceberg manifest file, which is statistics file, helps improve the performance of reads as well. Another very important performance related update, which I was personally looking forward to, was the change in default write distribution mode. So merge, for example, merge write as well as some inserts, they end up generating a lot of files in Iceberg without default write distribution mode in Spark, which is none by default without 1.2.0. While this is the cheapest method and basically as an old behavior, it did make sense for the community to kind of move ahead and with changing the default distribution mode to hash. So now the default distribution mode with Spark is hash. And I actually was able to test this out myself. And basically I used the TPC-DS data set. And I really saw a significant reduction on the number of files generated with this particular setting on, which really improves the write performance by a lot. I can share some more details as I write and progress towards a blog or something like that. But I think this is really an important improvement that I personally saw as well. And finally, we have another PR which avoids planning a check to. So basically, this is a PR that try to optimizes the delete operation. And instead of referencing the actual data files, the idea is to like do a metadata only delete. Metadata only operations are kind of lightweight operations and they are not costly. So basically, you're avoiding planning a scan to check whether a metadata only delete is possible if the delete condition always matches the entire partition. So this improves the write performance by a lot as you are dealing with metadata files only here. So that was all about Spark and performance updates. Let's quickly look at what has happened on the Apache Flink side. So Flink is another engine used heavily for streaming application, and the Iceberg Flink combo is really maturing day by day. Super interesting as well for like both the communities. So some of the key PRs that I wanted to discuss today are number one, the metadata table. Basically the ability, I think I mentioned this before with the human readable metrics, but the metadata tables are super important in Iceberg. Basically, it allows you to do things like, okay, how many small files do I have in my environment? How can I do some data quality checks? How do I do some data quality checks? How many null values are added per writes in a particular table, Iceberg table. So those are the kind of things you can basically analyze using the Iceberg metadata table. And with this PR, you can basically query an Iceberg metadata table directly from Flink SQL. So that's really a huge benefit for the Flink community when you're dealing with Flink SQL. The next one is around the same branching and tagging capability in Iceberg. So with this new change, we can write to Iceberg branches in Flink Sync via an API. So this allows people using Flink to leverage the same branching capability and same data as code approaches in Flink and implement various use cases like I was talking about with write, audit, publish, and those kind of stuff. So again, we needed to have that ability in Flink as well. So that's really good. The third one is around adding throttling support for streaming read. I'm not like entirely like I'm not really an expert with like streaming data, but at a high level, split discovery throttling is basically a mechanism used for streaming read operations. So it is designed to control the rate at which the partitions are discovered and processed during streaming data ingestion. So in certain scenarios, the rate at which the partitions are discovered can overwhelm the system, and it can lead to potential performance degradation. So this particular PR, it helps mitigate that issue. So probably in Iceberg, there are like, as per the PR that I've read, there are two scenarios when throttling is kind of desirable. One is when we have a large backlog. For example, you started the streaming job from the earliest snapshot and you have a large backlog and you have to control that kind of, streaming reads support. So, you set a threshold towards that. The other, scenario can be you have intentionally delayed consumption. So for example, if you have a stream join job reading from two different Iceberg tables, the first table has maybe more real-time data and the second table is typically later arriving data. Then it would be great to delay the consumption for that second table, by, for example, let's say, the time frame to make that kind of like alignment in terms of the event time. And this way we can reduce the join window in Flink state. So that's really good as well. So this PR really, helps you to control that kind of support. And for the last one, currently the Flink Iceberg commits are identified by the table and the job ID. So the last one basically deals with the enabling multiple Flink sync support. So when you have multiple Flink sync, it can become problematic, right? Because right now, the only way those Flink sync are identified, the commits are identified, is by using the table and a job ID identifier. However, when we have the same table for the same job, then you don't have a unique ID to identify that, right? So this new PR adds another identifier called operator unique ID to the snapshot summary to basically deal with multiple Flink syncs. So, you don't miss out any kind of checkpoints and updates. Okay, so moving on to Dremio Sonar compute engine updates. Dremio Sonar has seen a lot of maturity and improvements in the past few months. We have been really improving and we have been focusing on how to really make Dremio Sonar legit, basically a query engine that can deal and work seamlessly with Iceberg table. So one of the first thing is the ability to just take JSON and CSV file and convert them into Apache Iceberg table using Dremio's copy into command. And as you can see in the screenshot here, you can just a copy into command, and you can just give the location and that particular file format, and it will be converted to a Iceberg table. So copy into will also take the values from your CSV file and basically coerce them into a schema of the target table. So that helps you to not do your type conversions manually. So that's really beneficial as well. And it's a very simple interface in Dremio Sonar. You can just use this particular SQL command to do that. So next, we have the ability to rollback Iceberg table. Rollback is a pretty important capability that Iceberg facilitates and allows to seamlessly deal with things like for example, like in data incidents, right? So let's say, you had some ingestion job and, that ingestion job inserted some wrong data and it directly impacted your tables that were being used by downstream analytical apps, for example, your BI tools or, machine learning models or those kind of stuff. What Iceberg does is Iceberg maintains historical snapshot, right? Like I was talking about. So what we can do is we can either roll back to a certain timestamp when the commit was made or to a particular snapshot ID. And this is what the same thing you can do now with Dremio Sonar as the compute engine. So you can roll back a table to a particular snapshot based on the ID, as you can see in the image, or you can just go back to a particular timestamp and have your tables roll back to a particular version. Another very important new feature that recently was released with Dremio Sonar is optimizing Iceberg table. So Iceberg tables are constantly being written to and edited by different engine and tools. And as we do that, the number of data files also increases a lot. And these data files can also be smaller in size, right? And we know the impact of small file. We know the small file problem in the world of big data. So that can really impact the performance of the queries. Another thing is that as the number of data files increases, the number of metadata files also increases. So basically, the number of manifest files will also increase. And these manifest files, they basically help you to prune unnecessary data files and speed up query planning, right? However, for Iceberg table that are constantly being updated, like for example, with a streaming job or user performing constant DML updates, the number of manifest file can also grow over a lot of time. And also the clustering and the way the metadata files are organized might not also be optimal. So this suboptimal manifest can really impact the time it takes to plan and execute a query. So Dremio enables you to optimize query performance, leveraging the Iceberg API. So now you can do this optimization directly from the Dremio Sonar to basically maximize the speed and efficiency of your queries. So all you have to do is, for example, you can see one of the optimized command here, the first one, which is optimize table, that particular demo example table. And what I'm doing here, I'm basically rewriting my data file to a particular size of 256 MBs and making sure there are no small files. Another important thing here is that you can also optimize a particular table by specific partition, for specific partition. So here you can see I'm basically optimizing the table for a specific partition, sales year 2023, which really allows us to do things at a granular level. And like I said, you can also rewrite the manifest as well with Dremio Sonar. And another much needed feature is the vacuum feature. Vacuum basically allows us to remove snapshot that we no longer need. Like I said, every update, write update that you make to Iceberg table, it is captured as a snapshot, right? And the more you do those kind of update, the more snapshot you will have. But you don't obviously you need snapshot to keep the historical timestamp and historical time travel or rollback kind of thing. But at certain point of time, you might not need all your snapshot, and there are GDPR policies and those kind of things. So you might want to remove this kind of snapshot. So here in Dremio, all you have to do is use the vacuum command, and basically it will clear up all the unnecessary snapshot and the related data files, metadata files, whatever it is. And you can use different filters. As you can see here, I'm basically expiring the snapshot that is older than a particular timestamp, but I'm retaining the last 20 snapshot. So these kind of granular level flexibility helps really in controlling my environment and kind of managing those maintenance strategies. Great. So now moving from the JVM to the non-JVM environment, PyIceberg as a standalone library has been maturing every single day. And since it's a Python-based library, and Python is a hugely used language in a variety of fields, for example, data science, BI, data engineering, software engineering. So the library in general has received a lot of traction. If you are new to PyIceberg, I would highly recommend looking at the PyIceberg documentation. I can share again the link after this, but it can help you get started with the library. But we also made a lot of videos and blogs in Dremio around how we could use PyIceberg, and I can share them after the session. But in today's presentation, we are going to take a look at what happened lately with the library and what's really upcoming for the PyIceberg library. First, this is already available today, is the ability to prune full data file. So all you need to do is basically call the expression library and pass the desired value. So for example, here you can see in the screenshot, I'm basically passing a filter which says equal to the role developer advocate, and I'm trying to return that iceberg scan table based on that. So what I'm trying to do here is I'm trying to skip full data files and I'm trying to prune data files. So this is one of the things that we have right now with the PyIceberg library. We can just basically prune data files, and we can basically pass in a filter to the expression library and help prune those data files. The next one is basically we should be able to convert an iceberg table scan to a array data set. So as of today, we can convert an iceberg table scan to an Apache Arrow, a Pandas, or DuckDB object, which allows us to run analytical workloads such as data analysis and machine learning, etc., using the iceberg dataset. So what you essentially do, you basically read that particular table scan. You can just basically convert that iceberg table scan to a Arrow or a Pandas or the DuckDB object, and you can basically build downstream analytical application using that. That's a great way to build analytical application directly using iceberg, right? So this new change, it adds and allows us to convert an iceberg dataset into a array dataset. Again, if you're not aware of array dataset, is basically designed to handle large-scale datasets and enable distributed data processing for training machine learning model. So it can be really helpful for this. And all you have to do is basically take that function to array, and it allows you to convert to that particular table. Then we have the limit parameter. Today, the only way to preview the table for analysis and those kind of stuff is by using the filter expression. However, the limit parameter would make this super easy and flexible, and you can just add the parameter in your query, and you are good to retrieve the rows that you basically need in that particular way. Another one that I have here that's also upcoming is one of the bug fix for positional deletes. So what was happening is after deleting rows from a particular iceberg table, specifically with Athena as the compute engine, PyIceberg when you were using PyIceberg to do a table scan, it was still retrieving those deleted records from the table, which shouldn't be the case. So now those because the positional deletes were not taken care with PyIceberg, now they are taken care with the new release. And in the new version of PyIceberg, we should have this particular fix, and they should be working as expected. And the last one is basically the one that I added this morning is basically I saw a Google Cloud Storage support for PyIceberg CLI. So now we can basically have the support for Google Cloud Storage in the PyIceberg CLI, and basically try to do IO operations from the Google Cloud Storage. Again, I haven't really delved more into this, but I can do it after this. PyIceberg, what can be done? So this is just a way, this is just an application that I recently built where we can basically, this is just a Streamlit dashboard that I'm using. I basically built out a tool that kind of helps you use PyIceberg and do convert it to a particular DuckDB object or a Pandas object, and build your dashboard using Streamlit and tools like Streamlit. So it's a good example just to see what state of the art is possible with PyIceberg, and eventually what is going to be coming out, and in general how we can use PyIceberg as basically a standalone library and create these kind of applications. So I also basically provided a DuckDB interface because I was reading the table scan and converting it to a DuckDB object, like I was discussing with the Ray dataset. So I converted it into a DuckDB object and allowed basically an interface to like query this particular iceberg dataset using DuckDB. So that's something again super interesting as well. Again, this is just an idea to show that this is something possible with PyIceberg, and as we mature, we are going to see more of this. So that is pretty much with what's currently happening in the Iceberg project and what was released in the past few months with Iceberg 1.2.0, the compute engine side, the PyIceberg side. We saw the performance improvements on the Spark. We still have to, for example, like learn how the community is reacting to those new updates, how the performance improvements have been. It'll be super fun to understand like how if there are any like issues around that. Also, like, in general, it's a good idea to know about like what is coming up. I think I just, put together a snippet. I'm not going to like cover on these particular parts, but, now we are having a support for Spark 3.4 in the next release version 1.3.0. So that is something to be super excited about. There are so many new features in Spark 3.4, and I think we can leverage those features even with Iceberg. So that is super exciting for me. Then we are adding a rewrite position delete file procedure. So basically, at this point of time, if you wanted to rewrite your data files or rewrite your manifest, you can use a Spark procedure to do that. However, if you had to do that for your delete files, you cannot do it. And the new procedure, rewrite position delete files, it helps you to do kind of like use that Spark action and like do that rewrite of the delete files. We also should see some improvement in the distribution and ordering in Spark 3.4 and the new release, and some other upcoming updates around local sort for merge, currently check, and how you can basically improve merges and improve the right performances and stuff. So that is what basically brings us to the end of this particular discussion, and it was really good to like go through the overall updates in general, what has happened. And I'm open to any questions that you might have about what's coming, or if any of these features really interest you, or if you have any questions around these features, I'd be happy to take that as well. Thank you so much.
Hey everybody, welcome back. And now it's time for Q&A. So again, if you have any questions, please put them in the Q&A box. We'll start off with the first question. We got a few minutes to get as many of these questions as we can. But first question is, how do I implement data quality checks like write, audit, publish in Iceberg using branches?
Right. Yeah. So, write, audit, publish is a great data quality pattern to implement for your data engineering workflow. So I think, basically the whole point is that you validate your data sets in a non-production environment, right, before you push it out to the production table, because you want to make sure the data quality is up to date, and you want to make sure it's as per your expectations that you have set. So what Iceberg does is that with the branching capability, now basically you can like create a branch of a particular snapshot, and within that branch you can write you can do your quality checks in that particular new branch. So you can, if you have some ETL ingestion job which is going to insert some new records in that branch, you can basically write it to that. You can run your, you can use different tools or like Python code to validate that. And then, depending on whether it kind of like expects as per your expectations, you can go ahead and like push it to production table. I see another question that you've already answered, Alex, like with the Delta to Iceberg migration and how ZOrder. So yeah, that's pretty much it. Like, you basically you have to do that, run that strategy again, like, but yeah, the order should be maintained in some way. Yeah.
Another minute for anyone to put in any questions that they would like answered. So going once, going twice. And again, Dipankar, thank you for that very jam-packed, super full, awesome presentation.
Yeah.
That was a whole lot of fun. And again, you will be presenting again next week. What's going to be what are you talking about next week?
Yeah, so the next week is going to be how to do machine learning experimentation and reproducibility in a data lakehouse environment. And we'll see how we can basically use Iceberg as like the foundation, and then use a Metastore like Dremio Arctic to basically build up more data as code abilities. So yeah, that's super exciting.
That's pretty cool. I'm excited. So remember, everybody, same bad time, same bad place here. And again, this episode, if you want to rewatch it, will be posted on Dremio's YouTube channel, youtube.com/Dremio, and on the Gnarly Data Waves podcast on Spotify, within 48 hours. So make sure to check that out. If you haven't subscribed to those, subscribe to both. And but I see no further questions. So with that, I think we'll wrap up today. Again, thank you very much, Dipankar, and we'll see you again next week.
Of course, yeah. All right. Have a good one, everyone. Bye.